Many thanks to Anne-Marie and to each of you for your time. Our agenda this week is making real the digital enterprise. And the digital enterprise, of course, starts with information technology. We're talking about operational technology. But you could say that the potential for the digital enterprise includes the work product of our Bentley systems users, all of these aspects of engineers' work that I'll call digital engineering models. Those create the potential for the digital enterprise. We realize, again, we make real that potential when the digital engineering models can serve as the baseline for operations and maintenance, the frame of reference for making decisions, and the digital DNA for the infrastructure assets that the engineers create and owners operate. So completing the digital enterprise would involve adding ET or engineering technology for that realization. And so at Bentley Systems, our software products are a start for that. Our comprehensive modeling environment, this year we talk about industrializing BIM, and I'll talk about BIM, leveraging the models as digital DNA, and a connecting data environment to make that possible. So I'm going to introduce the subject of the digital enterprise extending all the way through operations and maintenance by reference to a talk that I gave called a RAP talk for reliability at the International Maintenance Conference at the end of the year. And of course we said going digital for the digital enterprise. And I referred to something we call inspectioneering. So these are our offerings from Bentley Systems. They are applications for creating for infrastructure engineering, for instance, in process plants, but our cloud services environment for collaboration in project delivery and then for asset performance and connecting them complete the picture. So I mentioned BIM before. That means two things for us. We accomplish better project delivery for assets by way of greater breadth of information mobility, and that's on the CapEx side. But we also, and in CapEx, our products for design modeling and analytical modeling and construction modeling are part of creating that digital enterprise potential that I talked about, the BIM potential, if you like. Much should be expected from us at Bentley Systems because ARC's research shows that we lead or are close in many aspects of digital infrastructure important to you and your readers. But BIM means something else for us at the same time, better asset performance. And the BIM part of that is greater depth of information modeling for OpEx. And so here we add asset performance modeling as part of going digital. And that, as I say, would realize the potential for the digital enterprise. And much should be expected of us at Bentley Systems here as well, because in ARC's rankings, we also lead in categories of reliability software. So for us, we want to advance in both CapEx and OpEx at the same time. We could call that TODEX. And of course, we mean to take cost out of TODEX. And the digital enterprise and its realization would put all that together in going digital. And wouldn't it be great then if every manufacturer or process owner would have a ET environment with digital engineering models of this sort from our software, which could link into the OT inputs, for instance, MindSphere, and the IT attributes for an immersive contextual environment of this sort. And that is much to be desired, and you will go away with a yearbook of the Be-Inspired projects who've won awards in doing that sort of thing with our software. One of those, the winner in asset performance this year, was Danfoss. They have been doing remote monitoring of refrigeration. They used to be in the refrigerator business. Now, new business model, they're in the refrigeration business and have been remote monitoring that. And so my friend Richard Ruth has my favorite title. He's a product manager of services at Danfoss. He's going to speak here at the ARC Forum, and we have helped Danfoss advance this year from tracking and monitoring to using deep learning to predict refrigeration and energy. But I want now to go to the example of Emerson. They're a finalist this year in asset performance in our competition, and they use our AssetWise Amulet operational predictive analytics for their integrated operations center in Texas. And it starts with a skid of the plant environment, and the integrated operations center is all about not needing to go to the field for engineers, and so that operations command center needs to be kept up to date. So they actually bring in a different skid for each manufacturer, but that's great if this picture were complete, but as Jagannath said, it's a brownfield economy. In 98% of plants, you wouldn't have necessarily the same digital engineering models we showed earlier. We have an advantage even then, however, because the virtual world in which design and analysis occurs and the asset performance real world have in common geo-coordinates. Everything has a 3D geolocation, and a technology we call reality modeling can bring that together. Reality modeling uses digital photography. For instance, in this case from a drone, this substation in France, 286 images from a drone were then supplemented with some handheld photos from the ground, and you see that this is a reality mesh that goes right into the engineering environment and can even be continuously surveyed, because unlike laser scanning, this process from photography doesn't need any special equipment or special operators. But if you had photos, for instance, in maintaining this rail bed, the photos might not have the detail you would like. So in the UK, trains can have a laser scanner mounted on them, and then you would have scanned input of the rail bed, which you can now, with our software, process in context. So you have a reality mesh combining photography and laser scanning in this process of continuous surveying. And for instance, in this reality mesh here on the rooftop, each of the dots represents where a photo was taken from a drone or walking around. And in inspection, we might like to have a closer look, but it would be difficult to look through the photos until we use the 3D immersive image to find what we're looking for, and then bring in the photograph and go to where we want in the high definition, even to find the tags and drill down from there, for instance. So I proposed that we could call that inspectioneering, and that was an actionable opportunity for plant operators today. In inspectioneering, the engineer at his desktop will have the benefit of the continuous survey. For instance, there's that substation again, but it's brought into the engineer's engineering environment, for instance, our Bentley substation tool, and he can engineer in this brownfield, for instance, to replace that transformer or to look at its failure modes and degradation and expected life from its nameplate and so forth. Now, photography is interesting. Here in the field, this inspection would take note of spalling, for instance, and with photographs taken by that fellow there and uploaded to our reconstruction cloud service, as soon as that, the inspector could be helping the inspectioneer. He's now an engineer who has access to the field conditions in 3D. He has access to something else as well, the digital engineering models, for instance, the rebar at that location, to determine if, in this simulated case, there's really risk of failure and safety. Now, something about drones that we've learned in the past year. So these folks are experts, and they're doing a existing conditions survey of a communications tower here. And they're doing what they think is the right thing. They're taking 600 images of it. It's going to be processed with our context capture software into this reality mesh. And you see it might be useful for something, but if you had in mind structural integrity and corrosion, that doesn't look like a sufficient model for the purpose. So the point is that the inspectioneer, he knows what he needs detail of, he should be the one programming the drone, which he has done here. And the 600 photographs, for instance, can be taken from the right place, focusing on where he knows there's a problem or a degraded condition to monitor. And it turns out to be, it's not the case that a drone can't do a good job on a communications tower. It's just that the engineer needs to program the drone, as we've learned in this past year. So I want to go back to helping Emerson here. So that's an operations center involving this skid. Well, could we have the digital twin in effect of this skid? So our folks went to Texas, took a few photographs of that particular skid, and this is the reality mesh, which wouldn't have to be crated in, would it, to the remote, to the integrated operations center. That could be brought in from the continuous survey continuously. So here's a plant captured with photography and reconstruction, and then using tools to recognize and classify the components that are in the plant so that we can inquire into their properties and then next connect them up with Mind Connect and so forth for their existing conditions here going into the schematics, and using the immersive contextual model from continuous surveying to provide access to the whole of the digital enterprise for our operating plant. Now that can be done. Here's a context capture mobile. In this case, it's a simulated situation. Our intern in this case, we've got a pipe rack here of sorts just to show the concept. It's going to be photographed and then reconstructed so that there is a digital engineering model, a reality mesh model, available for purposes now. We're going into maintenance and operations, and suppose that this alarm keeps sounding here, which is maybe why this inspector is there creating something for the inspectioneer to work with. But he now is in the office and he's going to work out a maintenance solution. He's the engineer. He's using a Microsoft HoloLens in this case. He's got the digital skid, if you like, in his operations center, and he's going to work out a design here, for instance, using our design modeling applications to find a safe and convenient place that would be well informed, because he can actually walk in the shoes of the maintenance person in finding this solution. Well, that could be helpful, but suppose Emerson doesn't really need to bring in a skid, but rather now, this is the reality mesh captured with some photography on site a few minutes ago, or with a drone, and brought virtually into the operations center. But there is no operations center here. The engineer is now using a HoloLens in an empty room, but he's likewise immersed in the maintenance solution, which will be very well informed in this case with a digital enterprise replacement for the notion of needing a digital skid, and an integrated operations center therefore always available. So that's the kind of thing that we in Siemens have in mind to work on. We announced in November our joint initiatives to have, if you like, the physical digital engineering models that our users create work with the functional digital engineering models that Siemens does very well at. And the CEO of Siemens Process Automation showed this example at our conference. Here it happens to be that same plant captured with digital photography and our context capture software. Siemens has an application, in this case they call Walk Inside, being used here for health and safety simulation, perhaps to train someone if there is this safety problem in the plant, where to go to turn off the safety switch and so forth. But from this immersive environment to interface to the Siemens Comos engineering system, for instance, to look at the schematics behind this piece of equipment, and then we would now use MindSphere to go behind this to the OT environment as well. So in December, Siemens had its annual Innovation Day. This is the Chief Strategy Officer describing what we're working on together. Let's see if we can hear
We
him.
have announced a strategic collaboration with Bentley. That's a very important step. We have a very strong offering in our process automation solutions with Comos, which is a two-dimensional planning and design tool for process automation plants. And we're now combining that with the extremely leading 3D planning capabilities that Bentley offers. So combined, we will have an unparalleled and unbeatable combination of offerings for designing of process automation plants and manufacturing situations. But Bentley offers more. Bentley offers software tools to design, plan, and manage distributed infrastructures, maybe rail infrastructures, building infrastructures, grid infrastructures. So with the collaboration of Bentley, we are extremely powerful way, found a very powerful way to enable the digital capabilities of our infrastructure divisions, mobility, building, and energy management.
So it happens that we don't have any new press releases for you today. You'll go away with a folder of our recent press releases. The most recent of them is last week at Distributech with Siemens to talk about indeed working with energy management, as we will be working in this case with all the divisions of Siemens, and especially starting with MindSphere for all the good reasons you just heard, those who are with us for the Siemens conference. And our role will be at the level of MindSphere apps to integrate for integrated engineering with the digital engineering models from Bentley or otherwise, and especially to bring this immersive contextual interface that I showed, and for instance, which can start to pay off this year for your readers in their inspectioneering functions for the benefit of all of us in realizing the digital enterprise. Thank you. Be glad to have your questions. Yes, please. Dick.
You made an interesting, used an interesting term, industrializing BIM. Could you elaborate a bit on that?
So by BIM, it initially meant building information modeling. That's kind of forgotten, and it's if you go to China now, for instance, every asset project, every construction project has a BIM division, a BIM director, and so forth. It just means making things smarter. It has been applied generally in the realms of infrastructure, of road and rail and water and so forth. When we talk about industrializing BIM, I mean not only applying what I'm showing here in the industrial realm, I mean implying industrial processes for designing and constructing and operating plants and industrial assets. It's all about more replication, more fabrication, distributed path of construction, what we call workface planning and so forth, making more of a manufacturing process out of construction projects everywhere would be industrializing BIM. And we and Siemens together think we have a lot to contribute for that. Great question. Next question. Thank you. Yes?
Is there you mentioned all the photography, is there a video aspect to this at all?
So the way in which you can reconstruct 3D from photographs depends only on their overlapping. And the only limit to the accuracy is to what degree they overlap. When you're doing video, you're automatically doing overlapping photography. So video is the very best source of the photography, and it's why drones are such a natural instrument for the digital photography that goes into reality modeling.
So, but I mean, in the case of the tower, would you take like the 6,000 pictures and stitch them together to make a moving image if you needed it?
Yes, the longer, you're going to be immersed in the 3D model. You can bring it up on your phone in a browser and walk around and look around and so forth. It doesn't have to move. But if you have 6,000 photographs, you're going to get a higher degree of resolution than 600. And a drone flight is an easy way to do that. One can imagine in a plant having permanently stationed cameras. And I anticipate, just as the inspectioneer today was programming the drone, in the future the engineer will be, when he does a design, will be specifying where the cameras are to be embedded. The cameras that are disposable and will be renewed periodically and so forth. And video alone is a wonderful means of monitoring asset performance. For instance, you think of instrumented bridges. You can do almost as well as instrumenting a bridge with sensors and gravitometers and so forth by videoing what happens when a truck crosses the bridge. The displacements, our structural analysis software used to analyze and build most bridges in the world is doing almost as well without bothering to instrument the bridge by videoing it, if you can find a place to video from. These things are changing every year. It's really, and machine learning to analyze the videos we'll be talking about next year.
Great.
Terry.
When will the Bentley apps be ready for the MindSphere?
We've had teams in Germany for most of the past month, and it will be next quarter, I think. We'll have the first of those. It's quite interesting. You don't need to rely on the traditional librarians. We have lots of reliability software you're familiar with that works with that. But this democratizing the process and securing the process of the OT to combine with the IT and the ET, we're very enthusiastic about. Thank you very much. We can be done on time.